Basically, a Dodge is the first biopower partnership in the United States. It's a joint venture between Aruba and Duke Energy, I'd say. We launched this in September 2008. And it was launched by the chief executive officers of the respective companies. Duke is a Fortune 500 company with $43 billion in assets. And Aruba has got a similar amount of assets. They're an international nuclear energy company, but they really specialize in non-carbon electricity. They're in the wind, they're in the biomass. They do a lot of EPC work. Duke tends to operate things and own things, and Aruba tends to build things and design things. And it was a good partnership in terms of the pieces of the puzzle. The plan is to develop 12 operating biopower plants in the United States in the near term. Near term being 5 years, that was our target. This partnership really brings together all the necessary pieces of a completed project. These are the general pieces of a successful biomass project, and we or our partners that we put into the project really fulfill all the necessary slots on the football team, from the power, the real estate, the EPC, the O&M, the finance, and the fiber itself, feedstock. Again, this is a project that's early in its development. We're doing some preparation of some permits. We hope to file a permit here pretty quickly. That's one of the reasons we haven't taken the time to brief you. We don't know really where we are. We're in negotiations with fiber guys right now. And essentially, the project itself, I want to impart upon you the fact this is the first of its kind world-class renewable energy project. From the technology to the feedstock. It's a 55 megawatt plant. What the consortium of the Dodge is launched is one of the things we've learned from our EPC partner is the concept of a reference plant. Reference plant being a plant you design and claw as many costs out of it as you can, and then you build it multiple times. So we're pretty set on this 55 megawatt plant. We have other reference technology, but this is the one we're talking about here. That's one of the reasons I think France has prolifically nuclear power right now, because of this reference plant design. It ends up being cheaper to build them ultimately, and there's some O&M cost reduction. So ultimately, we're trying to get the price of the power necessary down so that it becomes a reasonable price to utilities. The technology uses an advanced fluid bed reactor. All that means is that the analogy that I use is that if you're going to burn a pile of leaves, you light them on fire and you boil them. And that's kind of the traditional, what they call stoker technology. But if you take a stick and stir them around and blow on them, they burn a lot faster. One of the things, a fluidized bed, it's just a kind of a technology. It's a big tube with some sand. We put some air up underneath it, and the sand expands, and that reaction takes place. It's kind of violent. What it does for us is we're able to take a wide range of moisture contents of fuel, which you have here everywhere, really. And traditional stoker systems have a tendency to, the typical systems you'd have in a biomass or a hog fuel burner, it's just not a great system, and they tend to be very, very sensitive to moisture, so they got to burn natural gas and oil for it to work, and it's not really efficient unless it's really running at the optimum levels. The other big feature of our project is our reference plant itself we use air-cooled condensers, which means we don't really have any water requirements. Generally speaking, in the biomass world, these plants are all located, first of all, I haven't built one of any substance in the last 25 years, but there's a lot of them around. Since you are making electricity, there's a big cooling load. And generally speaking, biomass plants are located right next to the water in some form, a big source of water. We use an air-cooled condenser, which means our requirement for water is 30 to 50 gallons a minute range. It's pretty minimal. Another way of saying that is our consumption of water is 90% less than a traditional project. What it does for us is we don't really want to get into a fight about water with whoever we do get in a fight about water. And we understand, well, even 50 gallons a minute, we were getting a little skirmish going. But essentially, what it does for us really is that we're able to move the project near the feedstock, as opposed to locating a mill in Longview, because there's a product that they have to get out, they need a channel. We don't need that. So we're able to get it closer into the feedstock, which means that less traffic is used, or less transportation is used to get the fiber to the market. It's just better for everybody. All we really need is an interconnection to the power system. And so our real two siting issues that we deal with nationwide is, are we close, can we get interconnected, and we are in a strategic location within the fiber basket. That's really why we're in Shelby. A project like this, we've had economists do studies. We've got one going on now at the University of Washington as to what the overall impact from an economic perspective is of a project like this. This represents a $250 million investment for our firm, our combined companies. There's at least 400 construction jobs during a 24 to 36 month period of time while it's being constructed. And it's a multi-million dollar annual investment in local fuel purchases, because we're going to, all this fiber is really coming from a local environment. It's a base load renewable, which is unlike wind and unlike solar. You get it when the wind blows and the sun shines. And the utilities appetite, generally speaking, is for a product you can count on. It's there when you want it, and it's a base load commodity. So it would replace a gas plant. You're not going to replace a gas plant with a wind turbine or a photoelectric cell. And it's deemed carbon neutral by everybody. There's a requirement in the state of Washington for the utilities to have a certain portion of their generating capacity that they sell to be renewable. This meets that criteria, and pretty much nationwide, it meets the criteria of carbon neutral or green. And there's a fairly substantial economic benefit both locally, and we think that there's an economic benefit that's really off the table back into the forests, because the feedstock we're really concentrating on is forest residues, material that currently is left in the forest and is generally as a slash pile of burn. That is basically been our discussions with the major forest fires. This is physically where we're looking. We've got an option with John in the port for a chunk of the Johns Ferry Industrial Park. We haven't concluded the lease, but we're prepared to work on that. It is, as you can see, pretty accessible to some Bonneville power lines, and it goes back to the Shelton substation, which is key for us. Interestingly enough, the transmission system, even though there's wires all over the place, there's some restrictions. It's a little bit tricky to get on that system, even with 50 megawatts. This is a little more detail of the site itself. It's the bottom portion of the site. I think it's, I don't know if that's south, John?
Right, south end.
South end. So we've done some environmental screening. We've got a pretty rigorous process we go through internally in terms of, is it a site that we can build on? Are we going to encounter some problems from an environmental perspective? Can we get it permitted, I guess is really the real issue. And we're prepared, we're actually in the process of actually doing some soil borings to make sure that we understand what the foundation would look like. And right now, we have a permit actually completed for the air, but we have not deposited and filed it yet, and that'll happen in the next few weeks. I just wanted to make sure that we had this discussion, so we have an open line of communication when this does happen. This is a little mock-up of what one of these looks like. This is one of the first of its kind in the United States. There's several in Europe. Europe's a little ahead of us in the whole renewable energy side. You can see that big thing in the back is the air-cooled condenser, so it's a pretty substantial piece of the design. And one of the things that takes place, if we use air-cooled condensers, we take a little bit of inefficiency on our power production, and we make a little bit of that back. So if you just looked at pure unadulterated making money, you would put an air-cooled condenser on the back.